Okay, we are live. Hello, everyone.
Hello.
Today we are going to do a very shallow dive into the Ethereum Layer 2 ecosystem. Um, and I am no expert on it by any means. So I'd like this to be quite an open discussion. And my limited research, I'm going to kind of present to you and just kind of discuss the different flavors that currently exist in the Layer 2 Ethereum world. All right, yeah, cool. Everyone's muted. I'm going to share my screen, and I've got some slides to help. There we go. Let me switch to this view. All right. Can everyone see?
Yep, perfect.
Awesome. Okay, so exploring layer 2 solutions. So I think the primary thing to note here is that these layer 2 solutions, they solve the massive scaling issue with Ethereum. So that's a kind of primary focus is scaling, okay? And this discussion, you can see, is just going to be the tip of the iceberg. There is so much you can go into with layer 2. There's a lot of stuff into kind of these complex series. And I think I listened to a podcast the other day that said there's actually 20 different, they were counting more than 20 different flavors of plasma alone. So there's really kind of a lot to unpack from within here. Just to emphasize, it's really just the tip of the iceberg. So some of the stuff I wanted to discuss is kind of what is a layer 2 Ethereum scaling solution, which I'm sure you guys are all familiar with. The different types of scaling theories, and then kind of tying them in together and comparing the strengths and weaknesses between these two, and then just a final popularity contest between them. So firstly, what is layer 2 scaling solution? So it solves the issue that, I mean, you've seen the current gas prices recently. I saw they were up at kind of 600, which is absolutely nuts. And a layer 2 scaling solution kind of brings the cost down quite substantially, and it is also much faster. It allows for a much faster kind of transaction throughput per second, etc. But naturally, it comes at varying trade-offs. You don't get kind of the security or the full security associated with the main chain most of the time. Okay, firstly, what is a side chain? So a side chain is really basic. It is simply an Ethereum compatible independent blockchain. So as you can see here, you'll have the main Ethereum network, and you'll have some kind of side chain, which will be probably kind of a fork of Ethereum. And it often has its own kind of consensus mechanism and varying different kind of block parameters to make the chain a bit more efficient and stuff. I remember being at ETH Cape Town, and Vitalik was doing a panel discussion. You could tweet in some questions, and I asked, what do you think is going to happen with sidechains in the next few years? And he tends to believe they're going to be redundant, although I'm not so sure he still is of that opinion. But in its basic form, a sidechain is a completely separate blockchain. Some people say it's not even a kind of a scaling solution, but just another blockchain. And then with this little bridge emoji here, you can see they usually have some kind of communication between the mainnet and sidechain. For example, with transactions, you'll lock up the transactions on the one chain and you'll transfer to the other, as well as something called like an arbitrary message bridge. And that would be more along the lines of kind of states and as it's kind of the wording implies, arbitrary messages. Okay, so to discuss some of the sidechains that are in the current ecosystem, we have proof of authority over here, and they're a layer 2 sidechain. And instead of using, so how they do their consensus is they've got a subset of notarized US notaries that act as the validators. So they essentially aren't as decentralized because they've got these publicly listed group of people that are kind of validating the consensus mechanism. Then we have Matic, which uses kind of a proof of stake mechanism, where essentially it's similar to kind of what ETH2 is doing, and essentially people are incentivized to validate things because they've got kind of funds locked in. XDAI over here is another proof of stake and developed by the same people doing proof of authority. Scale is also another layer 2 solution, and they've got an interesting mechanism that maybe Jason could comment on a bit more, but essentially it uses some form of randomization to essentially have less active nodes. Am I correct in saying that, Jason?
So the idea is that they have lots of side chains that link. So with all of the others that you have presented here, like POA, Matic, and XDAI, they're a single blockchain that links to Ethereum. Scale is saying, why only have one? With Scale, as many, like anyone can create their own sidechain, and it's totally independent of the others, but you can then send messages between them with various methods. And the risk of that is that if you have too many sidechains and not enough validators, the security of those sidechains is compromised or lessened. So they've got a way of rotating who validates for which chains at frequent periods, basically. So it's a little bit better than if they didn't have that.
Okay, cool. And then this last one here might not be as familiar to everyone, but it's Quorum, which is a sidechain, but it is originally developed by Consensus. It is a private sidechain. I think that's the core difference. I believe it's proof of stake, and I think JP Morgan has purchased it some way or form. Okay, so sidechains, some people actually say they're not actually a scaling solution, they're just a separate chain. But now we come to kind of state and payment channels. Okay, so some people may have heard of Raiden, they're quite a popular one. Connext is another one. But essentially with a state payment channel, users deposit into kind of a smart contract on the main chain, and then they open a channel between people off chain. And then how the kind of transactions work is they sign transactions between themselves, and then eventually the state will be submitted back to the blockchain. And there's kind of a dispute window when something's submitted back to the blockchain. A little bit too much alliteration in there. And so people can kind of invalidate transactions, but these signatures are kind of leveraged, built on top of each other between these channels. And I think what Raiden's, so one of the issues is it's not always 100% available. You don't have 100% availability because you require that these channels to be open the entire time for transacting. And one of the interesting things that Raiden's doing is essentially they've got, so in order for me to make a transfer to Marvin, I would have to create a channel with him, a payment channel, and transact between. But now I don't have a payment channel opened with John, but what Raiden does is as long as Marvin has a connection channel open with John, and I have a connection with Marvin, I can create a transaction via this kind of network. And so one of the kind of interesting things about Raiden and these state channels, since it's off chain, they are essentially kind of privacy preserving until maybe the withdrawal, and that's just the kind of the final state that gets updated onto the main chain. And then the difference between a state channel and a payment channel is pretty simple. If it's got a financial transaction or the thing being transferred over a channel is kind of a token of value, then it's considered a payment channel. Okay, now we dive a little bit deeper into Plasma.
Can I ask a question about
yeah, sure.
Side chains?
Sure.
That picture to me doesn't really show the advantage of sidechains in terms of it being cheaper and faster, because the networks are exactly the same size, right? So it's like if the nodes in the network are also the same kinds of nodes that are in the main net, network, then how is it cheaper and faster?
Great question. So I think the primary difference is often a different kind of consensus mechanism. So on the Ethereum mainnet, in its current form, it's a proof of work consensus mechanism, which is notably inefficient. But on, for example, Matic, which is a sidechain, they don't use proof of work as their consensus mechanism. They use proof of stake, which is much more optimal for speed because you don't have to compute these random complex computations. And so one can be kind of consensus mechanisms, but likewise, in this diagram, they both have the same number of nodes, but you could have a sidechain with maybe like only 20 nodes or something like that. So the thing to note is it's a completely independent blockchain with its own parameters that kind of are maximized for efficiency and often at a trade-off of kind of security, etc., or decentralization, but they're Ethereum compatible independent chains. So the kind of moving between them they're interoperable with each other. Make sense?
Yeah, that makes sense.
Yeah, I can maybe quickly add. So, like the main characteristic of sidechains versus layer 2s is that they have their own security, and essentially why mainnet Ethereum is so amazing is that it's got extremely high security. You can send like $1 billion in a few seconds, and after 1 minute, or I'm kind of guessing time, you can be like 99.9999% sure that it won't be reverted, and like every minute after that, it gets more and more strong, that security. And it does that because it's so decentralized and it's so big and it's got so much value is at stake with all those computers. Whereas a sidechain, maybe it's a group of friends, me, Denim, and John, we running the sidechain, and like if we get together and play a joke, we can destroy the sidechain. So it's a big trade-off of on security mostly to get speed. And then, of course, there's a trade-off of centralization. So on a sidechain, I could have 5 supercomputers with 200 gigabytes of RAM and the latest like 50 core CPUs, right? And there are blockchains that do that, like EOS, for example. The hardware requirements are very high just to run it. Whereas Ethereum strives to work on like a normal laptop from like 2010. That's like their goal. They want to keep that. That's like one of their core principles. Anyway, continue. Sorry.
Just to quickly, add on, Jason, what you're saying. That's sort of what we covered with the blockchain trilemma, the trade-off between security, decentralization, and scalability. Exactly what you sort of outlined now. And sort of the fundamental bottleneck is in a decentralized network, every node or computer has to process every bit of computation independently to confirm it's true. And if you want users with sort of standard laptops to be able to run the Ethereum network, then obviously there's a bottleneck at that little PC being able to process every bit of computation in the entire network. And as you let more people do it, it sort of becomes sort of less fast. As Jason says, you could have supercomputers doing it, but then only a few people can participate, and it's less decentralized.
That's a great way to put it. I really like that.
Yeah,
blockchain trilemma issue. And Sean, another thing to note is technically, like these test nets could be considered a sidechain. I've heard of people using kind of the test nets to do transactions because, essentially they're a fork of Ethereum, but they maybe have way less traffic, so less users and stuff. So you can have, it's not like a congested network. Alrighty, okay, coming on to Plasma. This is where stuff starts to get a little bit more complex, and I think Plasma was originally conceptualized by Vitalik and the guy that did, what was it? Was it Lightning Network?
Oh,
Joseph Poon.
Yeah. What is
Yeah, he works on
Oh, cool,
Lightning Network also.
But what is his first thing? What did he do before that?
He did work on Lightning Network. I don't think he invented it. Maybe he did.
But I mean, doesn't
not sure.
Lightning Network just use Plasma for Bitcoin?
No, Lightning Network's a state channel type thing.
Oh, okay. All right.
Like
Okay.
it's closer to Raiden and connects, like on your previous slide.
Got you. Okay. So Plasma is a scaling solution, and essentially, it's this graph here is quite nice the way to look at it. It has a series of secondary chains, and these chains are kind of structured as a Merkle root. So each node has two child nodes, and then that node can have another two child nodes, and then the computation can be done kind of off the main chain, and then so it's like sparse communication with the main chain, with the mainnet, and then a single hash can be submitted back to the main chain. So these child chains are also kind of referred to as plasma chains, and they use fraud proofs. So not every transaction is validated, but once it's submitted to the main chain, there's this concept of a fraud proof where someone can there's a dispute period, and someone can dispute this what's been submitted and say this is actually the correct one, and that way you can kind of rely on the same level of security as the main chain. There's some kind of inefficiencies around this where I'll come to in a bit of a later slide. And one of the biggest issues with Plasma is what's known as the mass exit problem. So if you have all these people making transactions down here, and for some reason there's a system or a lot of issues going on, and everybody tries to exit these Plasma chains at the same time, it creates a huge bottleneck at the top here. And so it's difficult so people can't exit very quickly. Likewise, to withdraw or to exit a Plasma chain, it takes around about 7 days or so. That's kind of based on this dispute period. And the next progression of Plasma is, sorry, here's another diagram. Yeah.
Although in the previous slide, is each level a side chain, or is the top thing like literally the blocks in the chain, and that second layer there is now splitting the main chain block into two separate blocks that can be computed separately?
So I think this would be considered a side chain. So yes, this is the main Ethereum blocks here, and this would be a side chain. And then this would be another side chain. So it's a series of side chains. Okay, well, I think this would be considered a side chain, and then this would be considered a separate side chain. And essentially taking this computation off the main chain into these side chains. Does that answer
what's the
Yeah, I think
anyone else answer a bit better?
Yeah, I think the main thing with Plasma is that it's got the security of main chain because you have these things called fraud proofs. Or no, maybe I'm confusing that word.
Fraud proofs?
Yeah, I'm not sure if fraud proofs are the right word for Plasma, but anyway, if anything happens on one of those chains, so let's say John Denham and I are running a side chain, like a Plasma side chain, and we like turn off our computers, so the chain just goes black, it just stops working. Then there's enough data on mainnet for you to submit a withdrawal to get the whatever assets you had on that side chain back. And then there's like a dispute period where let's say you do that, and then actually you try and cheat. You send another transaction, so you try and like spend that money and take it back on main chain, and then people can like basically submit cryptographic proofs with some sort of time, and once that time's elapsed, then like the main chain settles the dispute. So in theory, a plasma chain has the same security as mainnet, whereas other side chains, if the operators of those side chains go rogue and they like just, I don't know, break it or cheat or whatever, then mainnet is like, I don't know, like you're alone there. So yeah, that's kind of the main like high level difference. And also, like as Denim says, there's like 20 different types of plasma. Most types of plasma are not very expressive. So they're very scalable, but they don't allow you to write arbitrary smart contracts. Like the most famous one, I think it was one of the first types of plasma, was called Plasma Cash. And that was just for sending around tokens, you know, and there's different like models of plasma for different use cases, I guess. And that's what makes it quite complicated, because yeah, you have to really understand all of this before you can actually use it. Yeah, don't want to get too sidetracked.
Cool, thanks, Zach. So this is an example. This is kind of just unpacking that a little bit more. This is a Merkle tree, and it's a tree of hashes. So at each kind of transaction gets hashed up, and this kind of structure is quite important to note. And I'll show you an example of kind of an issue in a bit, but essentially, I'll come to that. And then a real world example is OMG Network, or Omigo, I think it was previously called. But they are quite big and well known because fairly recently USDT kind of moved on to OMG Network. But yeah, cool. Okay, then optimistic rollups. So the biggest difference, or the core difference between Plasma and optimistic rollups is optimistic. So Jason briefly mentioned this, but optimistic rollups support smart contracts. So they're EVM compatible. So this is, so as Jason was saying, there's like multiple different flavors of Plasma. And I think the main thing to note about optimistic rollups is they support kind of these smart contracts, but they are less scalable at Plasma. So there's kind of this slight trade-off. But it works in a very similar way, where these transactions, so eventually there's something submitted to the main chain, which is, and then there's a dispute window where these can be where fraud proofs can challenge the stuff. And I've broken this word up to 2 here, because optimistic is in the sense that it doesn't submit everything to the main chain, so it's optimistic. And then it's a roll up in the sense that it bundles transactions. So there's a series of transactions that are bundled into a single hash and submitted. And then this technology is currently around, which is quite interesting. And so the main kind of well-known one is called Optimism. And they've done 2 pretty interesting proof of concepts, I suppose, or demos. One with Uniswap that was called UniPig. And I don't know if anyone played with it, but it was quite interesting and super fast. And recently did another one with Synthetics. And this is the same Synthetics that you are probably familiar with. I've just noticed today that they've got new branding and stuff. We're gonna unpack this a little bit more once we get to kind of the comparison thing, which really kind of looks at the different methods and kind of compares them. Okay, ZK rollups. instead of using kind of fraud proofs to prove something is false, they use zero knowledge proofs to validate blocks. Okay, and zero knowledge proofs are a whole nother can of worms, but essentially they prove something, and this is, I'm just reading off here, they prove something without revealing something. Okay, so for example, if you enter a nightclub, if you're inside a nightclub, someone can prove or can make the assumption that you are over 18 without having to see your ID once, say you meet someone inside the nightclub or so. And there's 2 projects within it, and there's kind of a popular opinion that this is a better model than optimistic rollups, but notably more complicated. And there's 2 kind of well-known projects around this, which is ZK Sync and Loopring. I think one of the things to note here is that they don't support as much programmability, at least in its current format, as Solidity. So it currently is kind of a subset of the full programmability that you get on the Ethereum main chain. They are faster than optimistic rollups and Plasma. And again, they don't use this kind of fraud-proof challenge something. They use zero-knowledge proofs as kind of the thing, which allows them to be on-chain. Here's one that I haven't done too much research into. It's pretty new, and I can kind of discuss a little bit from here, from this diagram. So we've discussed Plasma, which is kind of off-chain, so it's got these side chains, and they use fraud proofs to challenge essentially fraudulent behavior. Then optimistic rollups also use fraud proofs, but they're on-chain and EVM compatible. Zero-knowledge ZK rollup uses zero-knowledge proofs, and they're on-chain. And then Validium, which is only kind of been talked about since June this year, as far as I know, uses zero-knowledge proofs, but it's not on-chain, which allows for considerable more scalability. But it's application-specific kind of use cases. But definitely worth diving into this one a bit more, because I haven't done my full research on this one. And this is kind of, this diagram here is what I was talking about a bit earlier, that you have an issue with, say this transaction is fraudulent, which inherently makes this kind of in the wrong state, subsequently this, which means these transactions down here are stuck behind this fraudulent interaction here, which allows people to essentially, they can kind of what's the concept of taking over and preventing these transactions from being a thing? They can
like a denial of service.
I think I'm looking for a term that's a bit more, but essentially they can hold hostage. So what was that hack where they spent the other company's gas fees by interacting with their contracts? Can you remember that one? Remember the insanely high gas costs, like transactions? Everyone was wondering before.
I think I know the incident, but I think in the end it turned out that it was like a mistake and it wasn't a hack. But anyway, yeah,
it allows people to hold hostage over kind of these transactions, which is kind of a flaw in the network. Okay, here's where it starts to, here's kind of this big comparison between all these different solutions. So state channels such as Raiden, side channels such as Matic, Plasma such as OMG Network, optimistic rollups such as Optimism, Validium, and ZK rollups. ZK rollups being ZK Sync, and I think Validium is Starkware, or they've got a product called StarkX. Okay, so if we compare kind of these different categories of security, performance, economics, usability, and other aspects, this is a great thing I have not created. I've pulled it from Matter Labs. which is the team behind ZK Sync, which is a ZK rollup technology. And we can kind of go through each of these and discuss them kind of lightly. So the liveliness assumption of watchtowers. So state channels and Plasma have to kind of keep up to date on what's happening with the main chain. Side chains are bonded. No, okay. The mass exit assumption, Plasma. That's
I thought the liveness assumption was that thing I was saying, like, let's say me, you, and John are running a state channel. We could all turn our computers off, and then the state channel is dead.
I can validate that now. This is a great article. I've got some things further down we can check out. But in this context, they're talking about the liveness assumption. Does the protocol require user liveness? Yeah. So do users need to be monitoring all on-chain activity of the scaling solution by themselves via trusted representative watchtowers? So this kind of implies what you're saying, but this is implying something slightly different.
Slightly different. So this is basically to know that things are working correctly, you have to look at all the data, whereas the others, there's obviously enough data, like metadata on chain on the mainnet, that you don't need to watch everything, something like that.
Yeah. A quorum of validators can freeze funds. So if you have collusion, essentially, of validators, can they cheat the network and steal funds, etc.? So with sidechains, of course, because it depends on how the sidechain manages these validators and stuff. If they have large-scale collusion, I mean, if you have something like EOS, I want to say, but if you have a sidechain that has maybe 10 nodes and those 10 node owners collude, they can steal funds. And that is applicable for Validium as well, because as far as I understand, it's off-chain and such. You've got kind of this mixture of these off-chain side chains so people that are kind of running those can freeze funds. So sorry, these two are quite similar, can freeze funds or can confiscate funds. Vulnerability hot wallet key exploits. Okay, so this is an interesting one. And when they say hot wallet keys, it's kind of referring to whether people can steal like these accounts that are like, for example, your MetaMask account or something. And I think the reason why state channels is considerably high is because you always need to have this channel open, which means you can't turn off your computer if you've opened this channel, which means what often happens is you delegate your kind of this to a server or something that's going to run for you. And therefore, the security vulnerability is quite high because now it's not directly within your kind of computer. It's more kind of centralized to probably a server that's running permanently, etc. Sidechains as well, dependent on which sidechain. Plasma and Optimus rollups moderate, Validium high, and then ZK rollups are immune to vulnerability hot wallet key exploits. Vulnerability to crypto economic attacks. I think what they're referring to here is kind of incentives, whether they're vulnerable to kind of poor incentive mechanisms. And again, it's very dependent on kind of the configuration, but sidechains are considered more high security risk because you will have sidechains that are particularly weak, etc. And then cryptographic primitives. So this is really pointing out that these ZK rollups in Validium is considerably more complex than these ones. And I think what it's getting at is that these cryptographic primitives are new and not fully explored. So they could be essentially expose themselves to certain risks, etc. And kind of charted territories. Performance and economics. So max throughput, and they've done it quite interesting here, where they've kind of defined the max transactions per second in terms of ETH1 and ETH2. So for example, State channels, they are you can have infinitely high transactions per second. It really depends on the off-chain kind of computational power that you're controlling. These side chains, they've classified as 10,000 plus transactions per second, but you can note that between ETH1 and ETH2, it's the same. There's no difference between the number of transactions per second. Likewise with Plasma, and then it gets a bit more interesting with optimistic rollups, because on ETH1 they forego some of the scalability of Plasma, and they can support 2,000 transactions per second, whereas with ETH2 they can support up 20,000 plus transactions per second. So this is really getting into the territory where it gets a bit more interesting. I know people kind of rave about Visa supporting 40,000 transactions per second, etc., etc. But if you take a look at something like Alipay is a Chinese service, and they do payments, and it's said that they support up to 250,000 transactions per second, which is still considerably more than all of these kind of options here. And it's worth noting that even with ETH2, these technologies are still going to be kind of essential to the growth of the ecosystem at a later point, because they kind of scale up much further when even ETH2 won't fully support the kind of current consumer demand. This
question.
Yeah.
What's TPS on ETH1 and ETH2 without the sidechain, or without these L2
So it
solutions?
was about 14 transactions per second on ETH1, but they've recently, because of the gas prices or something, I think they increased it to 50 transactions per second. I could be mistaken. But
I don't think it's that high. They increased it a little bit, but it's not much. I mean, I guess the thing is it depends on the type of transaction too and stuff.
For sure, yeah. I think it's, in terms of on average. I remember reading it as 50, but maybe I was wrong. And then ETH.
Okay, so these are considerably faster.
Yeah. But even so, even at 2,000 transactions per second, if you're going to go to mass scale, it's still going to be mass consumer adoption. It's still going to be too slow. It's not going to be able to support the full scale, which makes it interesting.
I mean, I don't know. Like you spoke about the Chinese company. I mean, maybe they're the biggest in the world, maybe not. Maybe they're an average. They're like one order of magnitude bigger than this, right? So you just have 10 ZK rollup layer 2 solutions. Is that you can just double these, right? You can make multiple of them.
Yeah, you could.
You?
But then they like, if you want to send a message from one optimistic rollup to another, then you have to go via mainnet, right? So you still have to do something on mainnet. So there are various bottlenecks and trade-offs, I guess.
And I think it's worth noting that Alipay is 250,000, not 25,000. So considerably more.
Yeah, it's basically one order of magnitude.
Sorry, I didn't understand. My mistake. Jason, do you know what the throughput of ETH2 is supposed to be? 10,000 transactions.
Something like that. To be honest, no one really knows for sure because they haven't built it. But yeah, let's say it's 10,000 transactions per second.
Okay. Which I think the kind of core point I'm trying to pass on here is that sidechains might become redundant in that scenario because it can kind of support more, but something like these new technologies will still have kind of applicable use cases once ETH2 comes around, as well as state channels, of course. Capital efficient. So the one thing to note with state channels is you have to kind of deposit the funds on the mainnet into a smart contract. And if you want to do transactions that are greater than you can't make transactions that's greater than the value that's locked in the smart contracts. So if you're interacting with DAI on Radar Network, if you want to send 20 DAI across a payment channel, and on the mainnet there's only 10 DAI locked in a payment channel, you can't support that transactions. And it's capital inefficient state channels exclusively, because you've got to deposit these funds and lock them up in, so the peacocks outside, lock them up in these inside these smart contracts linked to these state channels. A separate on-chain transaction to open a new account. Yes, for state channels. The cost of transactions, although they're all fairly kind of low, it's clear here that state channels and Plasma are more affordable. Fun fact. So withdrawal time refers to the time it takes to move from that layer 2 solution back to the mainnet. And with state channels and sidechains, it's one confirmation. With Plasma and optimistic rollups, because it has this fraud-proof mechanism where you can dispute something, it's usually a week. And I think these kind of caveats that are stated here are because it depends on how it's configured, etc. But yeah, and then with Validium and ZK rollups, it's 1 to 10 minutes. Time to subject finality, instant. Depends on the sidechain. One confirmation, 1 to 10 minutes. Client-side verification of subject finality. I can't actually remember what this refers to.
It's like, let's say I'm running on my phone. So when they say client, it's like not a full node. It's just connecting to the network without having all the data. And basically, it's like, can my phone know if the transaction went through or not? Like 100%.
Cool.
Like that's what finality is. Like, can the transaction be reverted?
In a state chain, because it's just a signature, anyone can receive that signature and know that it's verified, and they could submit it to the main chain. That's why I think it's got the full yes over there. It's very easy to just get that signature.
Cool.
As a client.
Cool. And then instant transaction confirmations, full and bonded. I'm also kind of spacing on this.
Yeah, instant again on state channels is as you receive that signature, you know it's final, because at any point you could submit that to the arbiter and be guaranteed to receive whatever.
My guess is bonded means it depends on the like main chain that it's connected to, or it's like it depends on something else. I don't know, to be honest.
All right, and then other aspects that are worth noting, and kind of this one's a biggie. Whether they support smart contracts. So state channels limited and Plasma limited. I think I can say with confidence that state channels are more limited, I want to say, or at least in the current kind of ecosystem. And then smart contracts are flexible support on sidechains, optimistic rollups, Validium, and ZK rollup. Although I know with ZK rollup in its current form, they don't, it's not as kind of progressive as optimistic rollups. EVM bytecode portable. No, yes, no. So since sidechains are EVM compatible, there's bytecode interoperability, as well as with optimistic rollups. And then this last point is quite an interesting one. It's native privacy options. So this kind of refers to another core issue or challenge of Ethereum, and that's not scalability, that's privacy, being able to have privacy in transacting on these networks. And state channels are inherently privacy preserving, but as soon as you kind of move back to the main chain or you withdraw it, it's all public again. And the same kind of privacy goes for Validium and ZK rollups. But sidechains, Plasma, and optimistic rollups are not privacy preserving. If that makes any sense. All right. A lot to take in, a lot of fairly unknowns still, but time to discuss a little bit of a popularity contest. So we've discussed a lot of these different kind of layer 2 solutions. And it's worth noting that a lot of these kind of exist in the ecosystem currently. And this is a kind of a table of the different layer 2 solutions and the amount of Twitter followers. Twitter being the kind of popular platform for blockchain companies. So as you can see here, go through XDAI is starting to get more followers. Starkware, which is Validium, they do StarkX. Proof of Authority Network, 18,000. Raiden, 26,000. Loopring, 40,000. Matic, 52,000. So I think it's also kind of leveraged off the size of their marketing budget, of course. But then it's notable that OMG Network has 284,000 Twitter followers, which I at first thought was maybe linked because they support Tether, USDT, but Tether's only got about 50,000 followers, so obviously just huge marketing budgets. But this is just kind of a basic table to talk about the popularity of these different kind of solutions. And that kind of comes to the end of the discussion. Any questions? Any thoughts?
I think Marvin's in the waiting room.
Yeah, sorry. By no means, but definitely kind of a entry-level view into these different layer 2 scaling solutions.
Yeah, I guess if you're building something now, like this is the philosophy we're taking, like it's quite difficult to really predict what will happen in the future. So when you're building a project, just go with one of the solutions. If they're going to give you funding, that's great. If they are going to help you, if they fulfill your needs now, probably just go for it. And just while you're building, just try and make things as upgradable as possible and as flexible as possible. Thanks, Ben. I love the peacocks too. And if in the future that network sort of dies, or the rest of the community decide to mostly focus on a different network that you're not using, at least you're upgradable and you've launched your product and you already have some users, and then you can migrate across. So yeah, it's going to be super interesting. Just don't be paralyzed by the number of options there are.
Cool. Thanks, Zach. Cool, everyone. See you next Friday.
Awesome. Thank you. Very cool session.